Hello friends, in previous lectures we have seen how to find voltage gain of circuit, and for this we need transconductance and output resistance. So we need transconductance and output resistance. So today we will see how to find out output impedance or output resistance of different configurations of circuit. So these are required so that we can find out output impedance or impedance of any complicated circuits. Okay, so today we are going to discuss finding output impedance of circuits. So first we will start with simple MOSFET. This is our NMOS, and we would like to find out R out from drain side. So if we draw its small signal, so gate is ground and small signal will come like this. So basically we apply one test voltage, say Vx, at drain node where we need to find, and we need to find out R out equals to Vx upon Ix. So here this is RO, this is GM, this is VGS. So this is source node, this is drain node, this is ground. Now gate node is 0, so GM VGS equals to 0. So if we are applying Vx voltage here, this is Ix current, then whole current Ix will flow from RO, not from GM VGS, because this term is 0 because gate voltage is VGS is 0 because gate and source both are 0. So Vx equals to Ix RO, Vx upon Ix equals to RO. So this is our R out. So resistance looking into drain node of MOSFET equals to RO. Now let's go to second circuit. Now we see cascading. So now we have this kind of circuit. So these are, say, VB1, this is VB2, and we need to find out R out. So what we will do, we will basically ground these two. Here we will apply Vx voltage, and this is plus minus. Now here VGS equals to 0, so we consider only RO. So this will reduce to this configuration. So here this is Vx, this is Ix. So so this is source node. So small signal we can draw like here is this. Say this is M1, this is RO1, this is M2, this is RO1, this is M2. So this is GM2 VGS2, this is RO2, this is Vx, this is like this is RO1. Now we apply KCL. So this is BS node. Now we apply KCL, and solving this circuit we find R out equals to Vx upon Ix equals to GM2 RO2 RO1. Now suppose GM2 is GM and RO2 equals to RO2 equals to RO1 equals to RO, GM2 equals to GM say, then R out equals to GM RO square. Now let's consider third circuit, which is cascading of three devices. Before going to cascading of three devices, so we can say that, say here this is say intrinsic or any gain, and we need to find out R out, and say this is some RS. So this is drain side, and this is drain side, and this is gain A. This is not actually gain A, this is basically 1 by A. So when we in cascading, when we see from drain side, basically this is a attenuator. So just remember only this point here, that this is a some block cascading some resistance, and say gain of this block is say some A, say A1, then R out equals to RS by A1. But when we see from R out, this is kind of a attenuator, so this gain actually equals to 1 by A. So this will be RS by 1 by A, and output resistance RS into A, where A equals to GM RO. So R out equals to GM RO RS. So you can develop institution here is that R out is RS into A is intrinsic gain of device. Okay, now let's consider three cascading devices. 1, 2, 3. So we need to find out R out. So first consider these two. So for these two, if we found out R out, say this is R out 1, this is A into RO, because here VGS is 0, so this is only RO. Now A is GM RO into RO, so this will be GM RO square. So for this I am assuming that all devices have same RO and same GM, or you can consider that this is RO1, this is GM2 RO2, GM3 RO3. In this way you can think. So this will be RO1, this is like this. But if we consider RO is same, then GM RO square, and all GMs are same, then GM RO square. Now what will be R out? So for R out, if we draw circuit again, this is GM3 RO3, and this resistance is R out 1. So here R out equals to GM3 RO3 R out, or A3. So this is say A3 equals to GM3 RO3 into R out. So R out equals to GM3 RO3 GM2 RO2 into RO1, or GM cube GM square RO cube. So R out equals to this. If suppose there are n number